What's up, guys? So we're going to continue on with linear, exponential, or quadratic. So Thursday, we talked about how to tell the difference between a linear, exponential, and quadratic function based on two things: its equation and its graph. Right. Today, we're going to talk about how to tell the difference between those three types of functions using a table. And I would say of the three representations, right? Equations, graphs, tables. Tables are probably the hardest, but all that to say, it's not all that hard. You guys will be just fine. So uh, let's take a look at this. Put that full screen for us. Cool. So we did all this. Let's go down to this next part, the table. All right. So this first table is an example of a linear function. And the way I know that is as the x values are going up by 1, -2, -1, 0, 1, 2. Look at the y values. +3, +3, +3, +3. You guys remember talking about this? Right? Linear equations graph a line, which means it has a constant rate of change, right? Which we call the slope. And the slope of this function would actually be 3, right? 3/1, because the x is going by 1. That's the run. 3 is the rise. But for this case, the way to be able to tell it's linear is that it's got a constant rate of change. It's adding 3 each time. That's how you tell the difference between whether it's linear or whether it's not, right? So let's move on. This next example is quadratic, and this is going to be the most new thing that we've done in this kind of mini unit we're doing. But it's pretty straightforward once you kind of get the hang of it. So if you notice what's happening here, from -6 to -6, it goes up 0. From -6 to -4, it goes up 2. From -4 to 0, it goes up 4. And then from 0 to 6, it goes up 6. So that's what these numbers are here. It goes up 0, goes up 2, goes up 4, goes up 6. So right off the bat, we know it's not linear because it doesn't have a constant rate of change, right? It's not going up by the same amount each time. It's not linear. So that means it's either quadratic or exponential. This is an example of a quadratic function. And here's how you tell. If it's going up by different amounts each time, right? It goes up 0, goes up 2, goes up 4, goes up 6, right? That disqualifies it from being linear. But I want you to notice something. Look how these numbers are increasing. From 0 to 2, it goes up 2. From 2 to 4, it goes up 2. From 4 to 6, it goes up 2. What we just did is what we call finding the second difference. Okay. The first difference is finding just the rate of change, right? It goes up 0, 2, 4, and 6. Once you realize it's not linear, check the second difference. See if these numbers are all the same. In this case, they are. They're all 2. That means if the second difference is the same, you have yourself a quadratic function. Finally, this last example, it's obviously going to be exponential, right? But how do we know that? This is exponential. It's similar to linear, but there's a big fundamental difference. And here's what I want you to see. As x is going up by 1, -2, -1, 0, 1. As x is increasing by 1 each time, look at y. What's happening here? Is it being added by the same amount each time? Nah, it goes from 0.08 to 0.4 to 2 to 10. That could look really random until you think about it for a second. And I want you to notice, look over here. From 2 to 10, you could add 8, or you could do what? Multiply by 5, right? 2 times 5 is 10. Let's see if that pattern holds. 0.08 times 5, you know what that is? 0.4. 0.4 times 5, you know what that is? 2. 2 times 5, you know what that is? 10. So it's being multiplied by the same amount each time. Exponential function. Okay. When you're multiplying by the same amount each time, it's exponential. And that makes sense, right? Because exponents are repeated multiplication, okay? Let's look at another example of exponential really quick. So this situation is the amount of days and the number of people who received an email, okay? Day 0, 8 people received it. The next day, 56 did, 392, 2744, 2,744. So if you think about that, it's not being added by the same amount each time. So if you start dividing these, what you're going to see is that every time you're multiplying by 7 to get to the next y value. When you're repeatedly multiplying by the same number, that is an example of an exponential function. Okay. So that was pretty quick. If you have questions, let me know. If you need me to make another video, I got you. Quick recap. If a function is linear, its table will increase by the same amount or decrease by the same amount. In this case, it's adding by 3 each time. That makes it linear. The next example was quadratic because although it wasn't being added by the same amount each time, goes up 0, goes up 2, goes up 4, goes up 6. If you notice, when we found the second difference, meaning find how these numbers are changing, they're going up by 2 each time. When the second difference is constant, that gives you a quadratic function. And then finally, an exponential function is where you're multiplying by the same amount each time to get from one y value to the other. Now, the last thing I'm going to say is these rules, in general, they only work when you're making sure you're going by 1 each time on your x values. If you're not going by a constant rate on your x values up by 1 every time, then the way to calculate this is a little different. We're not going to worry about that for now. We're just going to stick to the basics for the time being. So send me a question if you got anything. Do the assignment today, get that grade up, and yeah, have an awesome rest of your day.